Hello everyone, my name is Abdul Ajerish. Today, my group and I are going to discuss how strong and weak acids react differently in solution. Later, we will show you how to calibrate the pH meter, but first, let's talk about how strong and weak acids react in solution. First, let's talk about strong acids. Strong acids dissociate completely into H plus ion when aqueous phase. In solution, hydrochloric acid dissociates into hydrogen ions and chloride ions. Ka of strong acids much greater than Ka of weak acid. And now Mingmar is going to discuss and explain to you how weak acids behave in solution. Thank you.
Thank you, Abdul, for his presentation. Now, I'm Mingma Sherpa going to describe about the weak acid and its behavior in the solution. So, weak acid partially dissociates into hydrogen ion when it is in aqueous phase. For example, when we dissolve an acetic acid in the solution, it will give us hydrogen ion and the acetate. So over here, acetate is a conjugate base, which is a strong conjugate base because the acetic acid which we are dissolving is a weak acid. So how you can decrease the behavior of hydrogen ion in the solution is by adding a buffer solution or by adding a conjugate base so that it can react with hydrogen ion in the solution by forming more reactant or by reversing the equilibrium reaction so that we can decrease the amount of hydrogen ion in the solution.
Thank you, Mingmar. My name is Ross Cochran. I'm going to talk to you about how a buffer solution works. So a buffer solution is of any pH which helps to resist changes in pH. So for this weak acid solution, it's acetic acid, hydrogen ions, and the acetate ion. It would bond to these hydrogen ions and reverse the reaction towards reactants. For the strong acid, it would bind to these hydrogen ions and help to resist changes because this strong acid is going so strong in the product direction. So that's how it just helps to resist changes in pH. So thank you very much. Now we're going to take a look at how to calibrate a pH meter. Alright, here we are in the lab. First you want to rinse off the probe with distilled water, get the excess water off, put it in the buffer 7 solution, hit sensors, calibrate now pH, calibrate now, and put in 7.00 and keep. Rinse it off again, put it into the buffer 4 solution, hit 4.00, keep, and OK. We're going to rinse it off again. We want to make sure the pH meter is calibrated correctly, so we put it back in the buffer 7 and it is. We're going to rinse it off. We're going to check the pH of some apple juice. It's like 3.72. It's pretty acidic. We're going to put the cap back on, make sure the probe doesn't get damaged, and document in the notebook. Okay, rinse it off. Put it into the buffer 7 solution. Hit sensors, calibrate now pH, calibrate now 7.00 and keep. Rinse it off again. Put it into the buffer 4 solution. Hit 4.00 and keep. Okay, and we're going to check the pH of some acetic acid. Let's see, 2.71, so pretty acidic. We're going to rinse it off. Put the cap back on. Okay. And one more time. Rinse off the probe with distilled water, put it in the buffer 7 solution, sensors, calibrate now pH, put in 7.00 and keep. Put it into the buffer 4 solution, 4.00 and keep. And go ahead and make sure it's calibrated correctly. And it looks to be correct, so we're going to rinse it off and check some orange juice, see what the pH is. And that's pretty high, so if that happens, go ahead and recalibrate it, because really it should be around pH 4 for orange juice. So, we'll put the cap back on and document in the notebook. Thank you for watching. Have a good day.